making it live.
Perfect.
Okay, I think that's working. Did I do it right? Does it look like it's right?
Yeah.
Okay, cool.
Okay. Is everybody ready?
Yeah.
Yeah,
Oh,
one
let's start.
second.
Here we go.
My computer decided to be really slow right now, so it's taking a while to change tabs here. There we go.
And just sit next to the door.
Come on. There we go. Hang on.
Good.
There we go. Alright, so we all good?
Uh-huh. Question number 3 says, use the normal probability applet to find the combined area under the normal or the standard normal curve. That is to the right, and then equals 1.358. That's the answer to 3 decimal places, and the answer that comes up was 0.175.
Yeah, what?
Well, what did I get? Is that what you're asking?
1.3. We're finding the curve, the area under the curve.
So 0.82, yeah, 0.826, right? Because you.
So,
Yeah, I got 0.826 is what I got. I got 0.1745.
yeah, I got what Rosie got.
How do you guys get that?
Because I put the numbers in, and then it's the two like shaded areas that are on the sides and not the one in the middle, isn't it?
No, it's the one in the middle, isn't it?
But it says that is to the right of the z-score of 1.358, and then to the left of the z-score of minus 1.358. So isn't that the two sides and not the middle?
Well, it says find the combined area under the standard normal curve.
Yeah, that's what I was thinking.
Oh, so if it's the standard normal curve, then you only, if it's always the standard normal curve, then it's always the middle.
Yeah, okay.
Okay. So then it'd be
0.826.
Yep.
Okay. Which of the following will have a similar standard deviation if 9 observations are randomly drawn from a population? Is it the second one?
Yeah, I think so.
Distribution of the sample means distribution of the new observations. Yeah, that would be the second one.
So which of the following results implies that the spread of X decreases as the sample size increases? That is the third wait.
It's isn't it the law of large numbers?
Yeah, I think it's the law of large numbers.
Okay. Where was that?
Large numbers. I'm not so sure.
I'll check my notes.
Because the large numbers is that the larger it's going to be, the sample mean is going to be close to. I think that's the central limit theorem.
Yeah.
That was my first thought, but I also don't know exactly.
Go back a minute here. Wrong class.
So the central limit theorem guarantees the distribution of X is normal if the sample size is almost large. I think it's the central limit theorem.
The law of large numbers again.
I think it is the central limit theorem because I've just checked my notes, and yeah, it says.
Okay. Okay. Let's do that. And then if it's wrong, we can always.
Go back and change it.
Yeah. So scores on the quantitative portion of the GRE are approximately normally distributed with. Okay, so this one Dan earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding with Diane's score? So that's the value minus the mean over the standard deviation. So the standard deviation
I think that's.
Huh? Well, that's the right way to do it, right?
That's how you find the z-score. Yeah, it's the value minus the mean divided by the standard deviation.
Yeah, so you do 150.8 minus 160.
Yeah.
No, it's well, because 160 is the value. It's the value minus the mean.
Oh, okay.
So it's
160
160. So it's 160 minus 150.8 divided by 8.8.
Okay, there we go.
160 minus 50.8.
I got 1.0454.
Yeah, so 1.045.
Yeah.
Okay, next one. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
Alright, so now we just need to take the z-score we got for the previous question, put it into the applet, and then just shade everything above it.
Yeah.
Yeah.
So 1 point.
So it's above that score.
Yeah.
So I got 0.148.
Yeah.
Yep.
Oh, wait. I didn't get that. Did I type this in wrong? What did you guys get?
0.148.
0.148.
You got 0.148?
Yeah.
Yeah.
And what did you guys shade? Oh, you shaded the left side.
Yeah.
Yeah.
No,
Okay.
You should the
right side.
You should be the right side.
Oh, yeah, the right side.
My applet's like not letting me click the right side. It only lets me click the left side. And I get 0.148 anyway, but that's only when I shade the left side. And it won't even like physically let me shade the right side. Isn't that weird?
That's okay if you. I mean, it's
It should be
basically the same thing.
Yeah,
Yeah.
it's just.
That's weird that you do that. Okay, anyway, sorry. Go ahead. Okay. So the next one says, a random sample of 5 students was selected to take the GRE. Their scores were, what is the z-score corresponding with the sample mean of the student's scores? Okay.
Okay, we're just looking. Calvin, could you let in Earl?
Alright. So let's see.
That end up being the same as the first one.
Yeah, that would be.
Because it's
Because the mean is.
because the mean score would be
Are you saying it would be,
is the mean score
0, or it'd be
is the mean
1.0?
score
I think it'd be 1.045 because the mean is the same as the score that she got.
Yeah.
so it's going to be 1.045.
Yeah.
So what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
What is the probability that 5 randomly selected score that is greater than the mean that is achieved by the students in the previous problem? Okay, so we're doing the new problem today. The new formula thing today where we're doing the sample mean minus the population mean divided by the standard deviation divided by the square root of it.
Yeah.
Fun problem. What's the standard deviation? So we're doing the probability for that?
Yeah.
I looked down.
Alright. Oh, what did I do? Oh, okay. I wanted that one. So what did you guys get for the z-score?
I'm not sure if I did it right. I got 2.3377.
Okay, so
What is the z-score corresponding with the sample mean?
yeah, I wasn't sure I did it right either, so hold on. Back up here, okay. Minus the 150.8 equals the 9.2. Divided by 0.8 divided by the square root. 5. So you got 2.33 or
Yeah, 3.377.
yep, 2.3377. That's correct. Okay.
Yeah? Okay, cool. And then everything above that, and then probability applet.
So then we need to go into our applet. Sounds like because it's looking for the probability, right? Not the z-score.
Yeah.
Yeah. So we enter in 2.2. And then we're shitting everything to the right of that. So I got 0.0087.
Okay, hold on.
I got 0.09.
Oh wait! I forgot to.
We're doing the grading.
Wait, I forgot to add a 3. So 2.3377.
So we all got 0.0097.
Yeah. That's
Yeah,
what I
it's-
said.
9.7 or 9.6?
I got
9.7.
9.7.
Got 9.7. Somehow I got 9.6. Maybe it's just the way my
Rounded. Because it rounds the fourth decimal place, which is
'Cause it's
different than normal.
Yeah.
Okay. 2.230. 3 decimal places. Oh, okay. I see what I did wrong. Yeah, okay. Now I got it right.
Okay, so the next one says, suppose the GPA of BYUI students is 3.5 and the standard deviation is 0.7. It is well known distribution of schools. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random sample, which represents the sample mean of 81 students who are selected? And I would say that it would be,
What is the shape of the sampling distribution of a random variable, which represents the sample mean of the 81s?
Well, it's above 30, so meets the criteria. That'd be normal, but
is it approximately normal? Because remember in the
Yeah.
preparation,
We're not. I don't think we're talking about this mean of the sample means. It doesn't say the mean of the sample means.
it represents the sample mean.
let's see.
I mean, it's a sample mean, but it's not the mean of the sample means. So wouldn't it just...
Well, let's see. In the notes here, it says that in order for us to compute probabilities, it says we need to first determine if the X sample, I guess, is normally distributed, and then it says that there's two cases where that's where it's guaranteed to be normally distributed, and that's if the parent population is normally distributed, and then the central limit theorem guarantees that it's normal if the sample size is large enough, if it's, of course, larger than 30. So
it's approximately normal.
Yeah, I think so.
I'm sorry, what?
Approximately normal.
I'm not so sure.
Would be right.
Okay, so the sample mean is the X bar, but it's not talking about the mean of the sample of means. It's just talking about a sample mean.
Okay. I get what you're saying, yeah.
What is the shape of the sampling distribution? So I think it's just talking about the sample of the 81 students.
Yeah, I know what you're saying as well. I'm not sure. I don't know.
Where in the notes can we even find?
Okay, what is the mean of the distribution of the sample means? Okay, so I was looking at the next question, because sometimes if you look at the next question, it gives you a clue about what the first question is supposed to be. But sometimes they just play off each other. So this question 11 is, what is the mean of the distribution of the sample means? See, when they're talking about sample means, they talk about... Yeah. Goodness. Okay. And hold on, let's see. Yeah, I'm not really sure.
Well, it also does say that it's left skewed.
Mm.
I don't know. Just the way it's phrased, kind of.
Yeah. Throws you off a
Yeah.
bit.
Yeah.
Is there one that we think, more
Well, it has
likely?
to be one of two of them, so we can always say like left skewed now, and if it's wrong, then we have another attempt.
Yeah.
It's just hard to tell because I can't figure out where in the notes it actually answers questions about that.
Well,
This is the shape of the
under
sampling distribution. Sampling distribution. Of the 81. Okay, yeah, we can always.
Alright, so then we're just gonna, let's see, because at the very top of the notes, like in reviewing it, it has that equation where it's the standard deviation divided by the square root of the sample size. So then, let's see, that'd be 0.7 divided by the square root of 81, which is 9, so 0.7 divided by 9. And then, I don't know if we take that and plug it into the applet, and then see if that's what it's supposed to be.
What is the mean of the distribution of sample means for all possible singles? Well, the mean of that would be the sample mean, right? For question 11. Okay, what question are we on? I'm lost.
Oh, I was still looking at 10, but maybe we should move on to 11.
Okay.
What is the mean of the distribution of sample means for all possible samples in a given? That would be the mean, wouldn't that? The
For all the possible
3.5.
How would you do this? I don't remember doing this.
Wait, what did you do?
What is the mean of the distribution of the sample means? Sampling distribution for all possible. Possible sample sizes. That's 0.5. Okay, so in parentheses on number 11, when it says that, okay, so what is the mean of the distribution of the sample means? It has in parentheses sampling distribution.
That's yeah, and that was the that would be the standard deviation divided by the square root of the sample size, which would be 81. So
So the standard deviation is 0.7.
yeah,
And
so
the-
0.7 divided by square root of 81, which square root of 81 is 9.
Okay, let's
So it'd be 0.7 divided by 9.
0.7 divided by 9. is 0.077777.
Uh-huh.
0.0, so it'd be like 0.77. Round your answer to 1 decimal place. So yeah, it would just be 0.1.
So okay.
Or would it be 0.8 since it's like 0.7777? It keeps going on. So then wouldn't you just take that number and round it up to 0.8?
Yeah, but it says to 1 decimal place.
0.1.
Wait, are we trying to find the for 11?
Yeah.
The mean of the distribution of the that wouldn't be the point, because it's not talking about the standard, because the standard deviation for the sample means is the regular standard deviation divided by the square root of the.
Oh wait, let's see. Yeah, the standard deviation of the random variable. Okay, yeah, that's.
It wouldn't be the what is it, the 3.5?
The 3.5 over the 31.
Because we're just talking about the mean of the distribution of the sample mean.
You can just put the mean down. Then it's like as easy as that.
So is it
Oh, it can be.
0.3?
One
Or
line.
For number 11? For number 11.
Yeah.
It'd be
Yeah.
We're just looking at for the mean.
It would just be 3.5.
yeah.
And then on the next one, it looks like we're going to find the standard deviation of the distribution of the sample means.
Which means then we take, which means this one would be 0.7 then.
0.7 what?
The 3 decimals.
Well,
this time.
it was like 0.7777. It kept going on.
Yeah, it was 0.077777. So
Yeah.
it's
Wait, so 0. Wait, so it's
0.77.
0. Wait, so it's 0.0777.
Yeah. So we'll just put 0.078 for this.
Yeah. Is that right?
number 11 is 3.5.
0.7 divided by square root of 81. Okay. Okay, so this is the probability the mean GPA for be less than 3.3. Okay. So we're on 13 now, right?
Yeah.
So
Find the
just take
z-score. 3.5 minus 3.3.
It's going to be 0.2, I think.
Divided by, okay.
Wait, what
What was
the standard
The standard deviation
was?
0.7.
So
0.7
7. I got 0.2. 2. Oh.
Okay, so the z-score? Are we still in the z-score?
Yeah.
For the z-score, I got 0.0317.
Oh. Okay, I did 0.2 divided by 0.7, right?
No, divided by 0.7 divided by the square root of 81.
Oh, okay.
Because
Wait,
we're doing the z-score for the sample mean, the mean for the sample means. So we're talking about the sample mean. What is the chance of having a sample mean that is? Nice. I'm talking.
Wait, what did you get for the z-score?
I got the 0.0317.
Okay, I'm gonna try that again. 7.
I did the wrong operation there. Sorry. I got 2 point. 2 point.
Was it 2.5714?
2.7.
2 point.
Okay, hold on. Okay. Let's go back. So it's these are such a pain.
Wait, okay,
Less
what
than
the first?
0.35 minus 0.32. No, did that wrong. 0.32 minus 3.5, so it's a negative. There we go. Usual. Thanks. Divided by. At a negative 0.2 divided by. What was the standard deviation again?
0.7.
0.7 divided by the square root of 81.
Oh, and that's what I got originally.
Mm-hmm.
Okay,
Remember
so
that? And then.
what did you guys get for the z-score?
I got negative 2.5714.
Okay, because I just got a negative 0.015555. Yeah. And I'm pretty sure I got the equation right this time.
Yeah.
Okay, so let's just do the problem.
Oh, okay.
Okay,
Oh, no,
so
I did the, okay. No, I did that wrong again. Oh my goodness. You're probably right. It's negative 0 point something.
Negative 2.57.
Yeah. Okay. I keep doing the operations wrong, but that's okay. You both got that. I'm pretty sure that's what it is.
Oh, I actually didn't get that. I didn't get that answer.
You didn't get that answer?
That's what Rosie got.
Yeah, that's what I got. What did everyone else get?
Okay, let me do this one more time because I keep inputting it in my calculator wrong.
Okay, so like I thought we were trying to have to do the value minus the mean
Yeah.
over
so
the
you-
standard.
Yeah.
The value,
Yeah, okay, it is negative 2 point. 2.57. No, just 1.71. Okay. So the probability would be 0.010.
wait.
No, I didn't.
Okay,
I
wait.
didn't get that. I got 0.0051.
That's what I got as well.
Okay.
Did
Okay,
it
Are
so
you guys
show
doing
you
the Wait, are you guys doing 13 or 14?
the z-score? The z-score? What did you get for the z-score?
Negative 2.57.
Oh, okay. I still have one of them, my tails on. That's why. So 0.0051. Okay, there we go. Got it.
Wait. Which problem are you guys working on?
13?
13?
Yeah.
You guys are working on 13, and you guys are at 0.0051.
Yeah. And then
But
just
it's rounded
round
to 3 decimals, so it'd be 0.005.
Mhm.
Alright, so now we just do the exact same thing, but shade to the right.
Yeah.
Wouldn't you get the same answer though?
Yeah.
Yeah.
So just 0.
Well, no, wait, for greater than 3.3?
Yeah.
Yeah. Because it's just the other side, isn't it? Or is it everything else?
So just
No,
so number.
because we're still working off the same z-score. It would just be to the right side, everything to the right side. It wouldn't be the same thing. It would be like the 995. is what I
Yeah.
got.
Oh, yeah.
That
Yeah.
makes sense.
0. Point. Yeah. So 0.995.
Yeah.
Oh boy. My computer is about to die. It's got about 10 minutes.
Oh, there.
We'll be fine. We just have this last question and that's it. So.
Yeah.
The United States Coast Guard assumes the mean weight of the passengers in a commercial boat is 185 pounds. The previous value was lower, but was raised after a tragic boating incident or accident. The standard deviation of the passenger weighs is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is an extreme. Okay, so that one means that, okay, more extreme, either above or below the mean, and was observed in the sample. So no of extreme or more extreme means that are not only interesting values that are lower than the ones observed. Okay? But also values are far as away from the mean as ours in the positive direction. Okay.
Mm.
Okay, United States Coast Guard. So the weights of a random simple 48 simple mean. Okay, so 177.6 minus 85. Divided by 7 divided by
26 point, right?
hold on. 48.
think that's about right.
So we're just looking at the left side of the problem? For the probability at?
Yeah, and then I got 0.623. Oh, so it'd be 0.624.
That's not what I got.
Yeah,
So
I
the
don't know.
z-score probability.
So we were looking for the z-score. That's the z-score I got was -1.9.
That's like negative 1.925.
2.
Oh boy.
So it'd be
That. So it'd be 0.02. Would it be 0.027?
I'm not sure because it says that it should be the ones lower than what we've observed, but also the values is far away from the mean as ours in the positive direction. So is that both sides?
That's what it sounds like.
what did you guys get as a z-score? Negative 1.4.
That is what that sounds like. So it's 0.549.
Yeah. Wait, 0.0549?
So 0.
I got 0. What? Why do I keep on getting so differently than you guys?
So did you get how we got the z-score for it?
Well, for my z-score, I did 177.6 minus 185, right?
Mm-hmm. Yep.
And then you divide that by 26.7.
Okay, so we're looking for, we're doing sample mean against sample mean. So it's 26, 20, what was it?
26.7.
26.7 divided by the square root of the sample, number of samples, so it would be 48.
Yeah.
So it'd be negative 7 point divided.
The root of 48 is okay, and then 26.7 divided by
What is that?
So did you get the z-score 3.85?
All I can hear is a bunch of like kids screaming or something.
Oh, sorry, that's my niece.
So for the
Yeah,
z-score, I
I'm
got
in a meeting right now, so
3.85.
I'm in a meeting for school right now, so I need you to be quiet so I can hear them.
3.85 for the z-score?
Yeah. So you did 26.7 divided by the square root of 48.
Okay.
Yeah. So I got 3.85.
I'm on the last question. My computer was about to die, so I had to plug it in.
So then
Okay, so
after
the
that,
square, okay, so it's 26.7 divided by the square root
48.
of 48. This is
And then you get
3.85. Okay, so
Uh-huh.
yeah, 3.85. Okay,
And then
so
you
you're
put
gonna
that,
divide. You're gonna take what was it? -4, negative 7.4, and you're gonna divide it by that number. The z-score.
-7.84.
Negative 7.4. Because that's what you get when you subtract 177 minus the 184.
Alright, so then you get negative 1.92.
Yeah.
Yeah.
Okay, and that's the z-score.
Okay, and that's what we had before. So negative
Okay.
9.2. Did they tell you how many decimal places over? Should I put that? I'll do it too.
So, and then it sounds like we're doing both sides to associate the left and the right side, is what it sounds like.
Alright, left and right.
On your
So
normal
then 0.
probability app.
Alright, so then 0.055.
Yeah.
Yeah, okay. There it is. 0.055.
Alright.
Okay, I'll go over them really quick. Number 3 is 0.826. Number 4 is the second option. Number 5 is the law of large numbers. Number 6.
Wait, which was number 5?
Oh,
Number
for number 5, I put the law of large numbers. Do we want to change it to the central limit theorem? We didn't know for sure.
That's fine.
I thought that was what we decided on.
Yeah, I put
Yeah.
what is there.
And then 6 is 1.045. 7 is 0.148. 8 is 1.045. 9 is 0.0097. 10 is less 2. 11 is 3.5. 12 is 0.078. 13 is...
0778? Because
Oh, I
it's
just
3
put
Zero.
digits.
0.
I have 0.078.
I have 0.
0.007.
Well, it's to the 3 decimals, so it needs to be 0.778.
But I got
Wait.
0.078.
You got 0.078?
Yeah, that's what I
Yeah.
have too.
Oh, okay, 0.078. Okay.
And then 13 is 0.005.
Okay.
14 is 0.995. 15 is 0.055.
Yeah.
Okay, so we'll go ahead and submit. I have a feeling we didn't do too hot on this one, though.
Yeah.
Yeah, we missed
Okay, 3.
3.
We
3
3,
and 5,
8,
8.
10. Okay.
Yeah, 3, 5,
Luckily,
8,
those.
10.
Okay. So now, for number 1, or for number 3. Okay.
Okay. I'm gonna write down the answers that we got right. That way we can. Because it's
So
not
for
like we can
5,
look. This is not like we can look at the. Okay. So 3, 5, and 8 and 10 we didn't get right.
Yeah.
so for 5, we now can put the law of large numbers.
Yeah, and I think,
that's what it looks like.
and then I think number 10 would be approximately normal.
All right, wait, mine's loading up here. Come on. Internet has not been cooperating with me today. All right. So let's see. So we need to change. So number 5, law of larger numbers. All right, and then what other ones?
Okay, so for number 10, we're going to do approximately normal.
All right.
And then
Let's see. So then we need to do 3 again.
Okay.
okay, and then 8 too. As well.
Yeah, 3 and 8.
So 3.
Did we just shade it wrong, do you think?
To right. Probably. I'm guessing if it was not in the middle, then it had to be on the sides.
Yeah.
All right. So then,
No, we're trying. Not then.
all right. So then I get 0.175 after rounding.
Law of not large numbers. Okay.
Okay, so the next one to do is
Don't do that.
Yeah, we're doing the just gonna look at this.
This, you know, you
okay. So how can we like? What do we do for 8? What's like the first step?
For 8?
Yeah.
So it's the z-score for 160.
It's 160. So
160 minus
we like add all of the something or what?
Yeah, don't we add them all up and then divide it by the total amount that's there, and then that's the
That's the mean.
that's the mean.
Oh, that's 160.
Yeah, that's 160.
yeah, it's just a probability for getting above
Well, because all we're trying to do is just find the z-score in number 8. So
We're just trying to find the z-score.
Yeah.
yeah, that's what it says. It just says find the z-score.
So 160.
So I wrote down the answers that we got right. Do you want me to read them off to you?
Oh no, because are we gonna? The answer to number 8 isn't 160.
No.
No, the answer to 180 is the z-score for 160, which is the same as
But didn't we get that one
6.
wrong?
Did we?
Yeah.
Yeah,
That's one
yeah.
wrong.
Because we got the z-score for that, and we got that one correct, and we typed it in for 8, and we still got it wrong. But I don't know if it could be maybe just like the quiz in and of itself is just like giving us the wrong answer when it's actually supposed to be the right one. I mean, we could just
Can you score it once?
we could just email her about that to ask about it.
Where is it first?
Yeah, I just think that one's wrong in general.
I'm just working it out again, like the full thing anyway, just to make sure. 11. So I didn't get the same as question 6 for the z-score for this one.
Okay, well, so what did you do for the z-score?
How did you start?
I think it's because when you do the z-score for this one, don't you do it with the when you put the square root of the thing in there? Whereas I don't think we did that for question 6.
No, I don't think we did that for question 6 either, but
I think what I got this time for the z-score was 2.337.
well, you know, that's probably what the problem is.
Wait, so how did you do it, Rosie? Can you tell me the steps?
For this one, you do the observation number, take the mean, and then you do the standard deviation divided by the number of like samples taken, I guess.
So it would be divided
Square root
by
1.
8.
So what I did was 160, take 150.8, and then I divided that by 8.8 divided by the square root of 5. Okay.
2.3. Okay. 2.338 then?
That's what I got this time.
Hey, you got 2.337.
But you have to round it up because it's 2.3377 something, and then you just round it up to 2.338.
I know, but I can do this morning, really, kind of like.
6.
Okay. 2.338. So should we resubmit it now?
Wait, what did we get from question 3 again? I didn't write down the new answer for that.
0.175.
Okay, can we just go through again to make sure? Because I don't. I might have miswrote something down.
Okay.
Do we want to go over the answers again?
Do you want to do them or do you
You could do them.
Okay, so number 3 is 0.175.
Okay.
Number 4, distribution of samples. Number 5 is the law of large numbers. Number
Okay.
6 is 1.045. Number 7.
Number 6. Number 6. Number 6
yeah,
is what?
number 6, 1.045.
Okay, 1.045. Okay.
1.045. And then number 7 is 0.148. Number 8
Number 8.
is 2.338. And then number 9 is 0.0097.
Okay.
And then number 10 is approximately normal. Number 11 is 3.5. Number 12 is 0.078. Number 13 is 0.005. Number 14 is 0.995. Number 15 is 0.055.
Where are those droppers? Can't find any of those droppers like that.
Woohoo!
Did we get
All
100?
right.
Okay. Tuesday. The next 2 Tuesdays, actually, I'm working until 8 o'clock my time, so I won't be able to do.
7.
I won't be able to do at the regular time. I could only do at like 9 Mountain Time.
Is 8:30 okay then?
Well, that would be 9:30 your Mountain Standard Time. I'm actually on the same. I'm not in the same time zone, but I'm on with California on my time.
Yeah, I'm Pacific time, so that's 1 hour behind Mountain Standard Time.
Yeah, so I could do 9:30. But 9:30, okay?
Yeah.
Okay.
So it's not like starting about now, but home.
No, it's an hour from now.
An hour from now. Okay, just because I'm like
An hour
17
from
hours different, so it's a bit I'm trying to work it out.
I know
That's right.
it'd be an hour from now. Yeah, that's right.
Alright, so wait, so we're going 9:30 Mountain Time.
Mountain Time, yes. So for me and you, it'd be 8:30.
Okay.
Wait, so I'm Mountain Time, so I'm 9:30.
Yes,
Yeah,
you're 9:30.
Okay.
Yeah.
Okay. Got
Alright.
it.
I'm pretty sure we can stop recording it. It's still recording. So.
Sorry.